All right, welcome to the Explainer. Today, we're going to pull back the curtain on one of the cleverest ideas in all of modern AI. How do you get these incredible photorealistic images from nothing, from pure random static? The secret, as it turns out, isn't some brand new invention. It's actually a super clever new use for a really, really old tool. For decades, one of the biggest challenges, one of the classic problems in image processing has been denoising. You know what I'm talking about, right? You take a grainy photo, maybe it's from an old camera, or you took it in low light, and the whole goal is to just clean it up, make it look clear again. Yeah, the whole field was basically built around this one idea: restoration. You've got a messed up input, and you run it through some smart algorithms to get a clean output. And I mean, after thousands and thousands of research papers, we got really good at this. Like, incredibly good. Okay, but here's where it gets interesting. Let's really dive into this, because this little shift in thinking, it changes everything. What if the true power of a denoiser isn't just about cleaning up old photos? What if it's actually about creating brand new ones from pure chaos? This one question, this simple reframing, totally unlocked a revolution in AI. So it all starts with understanding what a denoiser is actually learning about the world when we train it. See, it's not just learning what noise looks like, it's learning something much deeper. It's learning what an image is supposed to look like in the first place. I want you to imagine this huge, massive landscape. Every single point on this landscape is a different image. Now, most of it, the deep, vast valleys, that's just random static. It's visual garbage. But way, way up high, on these tiny, little isolated mountain peaks, that's where the good images live. You know, the ones that look like faces and cats and beautiful landscapes. So, if we want to create an image, we need a map to find our way to those peaks, right? And in the world of machine learning, that map has a name. It's called the score function. Think of it like a compass. No matter where you are in that giant image landscape, it always points you in the steepest uphill direction, the direction of more image light. Okay, so here's the catch. Actually trying to calculate this universal map for all images, it's a mathematical nightmare. I mean, practically impossible. But, and this is so cool, researchers found this absolutely stunning shortcut. And it all came from a statistical insight that's been sitting around for like 80 years. And here it is. This is the big reveal. When you feed a denoiser a noisy image, the direction it points back towards the clean version, the very noise it's trying to get rid of, that is a direct approximation of the score function. It's wild. By learning how to clean up an image, the denoiser implicitly learns the map back to those good image islands. All right, so we've got our compass. We have this denoiser that can act as our map. The next question is obvious. How do we actually use it to create a picture completely from scratch? Well, we use a process called Langevin dynamics. And I know it sounds super complex, but the idea behind it is actually really simple. You start with just a patch of pure random noise, total static. Then you ask your denoiser, or compass, hey, which way to a real image? It points. You take a teeny tiny step in that direction, add a little jiggle of new randomness so you don't get stuck, and then you just do it again, and again, and again, thousands of times. But as elegant as that sounds, this whole hill climbing idea has a massive, and I mean massive, fatal flaw. The problem really is one of scale. Those islands of good images, they're basically microscopic compared to the vast, empty ocean of just random noise. So when we start with pure static, we are completely and utterly lost in this pixel desert, millions of miles away from the nearest mountain peak. And way out here in the middle of this desert, our compass, our denoiser, it just spins wildly. See, the denoiser was trained on slightly noisy good images, right? It's never seen pure chaos before, so it has no idea what to do. Its guidance is basically random. Trying to get to an island from here would take an impossibly, ridiculously long time. And this is what brings us to the absolutely genius idea that really unlocked all of modern AI image generation: diffusion. So the problem is like trying to find a tiny needle in a giant haystack. What's the solution? Well, instead of looking for the needle, what if you could just make the needle as big as the haystack itself? I mean, if your target is everywhere, you literally can't miss it. So how on earth do you make the island of good images cover the entire space? Well, you do something that sounds completely backwards. You take all the perfect images in the world and you just conceptually blur them with a massive amount of noise. You basically smear their probability out across the entire landscape.
And this is how the process actually works. It's called annealing. We start our journey way out in the noise, but now we're standing on this giant, blurry, easy-to-find target. Then, with each step, we gradually reduce the amount of blur, and our denoiser just chases that target as it shrinks and gets sharper, step by step by step, until it finally collapses into a perfect, crystal-clear image.
And the payoff here is just huge. Instead of hundreds of thousands of steps just wandering around in that pixel desert, this whole annealing process lets us create a super high-quality image in maybe 1,000 steps, sometimes even less. That's a staggering jump in efficiency. I mean, this technique was so incredibly effective that by 2021, diffusion models had officially blown past the previous champions of image generation, which were called generative adversarial networks, or GANs. They weren't just making higher quality images, they were making images that were way more diverse too. So really, the key takeaway here is this. The next time you see one of those mind-blowing images from an AI model like Stable Diffusion or Midjourney, you'll know the secret. You'll know that deep down, it's really just a very, very clever denoiser that started with total static and chased a moving target all the way home. And that leaves us with a final thought to kind of chew on. We've just unlocked this completely new way to create structured, beautiful, complex art. And we did it all by just reframing a simple cleanup tool. It really makes you wonder, right? What other revolutionary technologies are just hiding in plain sight, waiting for someone to ask the right question?